Hello learners, this is Habeeba with Excelwithme. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is research methodology paper, topic correlation of techniques, the last subtopic, that is biserial, point biserial, tetrachoric and the pi coefficient we are going to discuss. Special types of correlation. The correlation we have learned is Pearson's product moment coefficient of correlation. The Pearson's R is one of the computational process for calculating the correlation between two variables we have learned in the previous videos. Nevertheless, this is not the only way to calculate correlations. It is just one of the ways of calculating correlation coefficient. Now in this unit we shall learn about special types of Pearson correlation, special correlation of non-Pearson type and correlations for rank order data. The special types of Pearson correlation are point biserial correlation and pi coefficient. The non-Pearson correlations are biserial and tetrachoric. The rank order correlations discussed are Pearson's rho and Kendall's tau. Now the first one is the point biserial correlation. Let's understand. Some variables are dichotomous. The dichotomous variable is the one that can be divided into two. Di means two. Two sharply distinguished or mutually exclusive categories. Now some examples are male, female, rural, urban, Indian, American, diagnosed with illness and not diagnosed with illness, experimental group and control group. So dichotomous, division of two variables. Here we will study in point biserial. These are the truly dichotomous variables for which no underlying continuous distribution can be assumed. Now if we want to correlate these variables, then applying Pearson's formula have problems because of lack of continuity. Now Pearson's correlation requires continuous variables. Suppose we are correlating gender, then male will be given a score of 0 and females will be given a score of 1, or vice versa. We can give males 1, females 0, or females 0 or males 1. Indeed, you can give a score of 5 to male and score of 11 to female, and it won't make any difference for the correlation calculated. Now point biserial correlation is Pearson's product moment correlation between one truly dichotomous variable and other continuous variable. Algebraically, the RPB equal to R, so we can calculate RPB in a similar way. Now, how we calculate this calculation of RPB? Let's look at the following data. It's data of 20 subjects, out of which 9 are male and 11 are females. Their marks in the final examination are also provided. We want to correlate marks in the final examination with sex of the subject. The marks obtained in the final examination are a continuous variable, whereas sex is truly dichotomous variable, that means male, female. Taking two values, male or female, we are using value of 0 for male subject and value of 1 for female subjects. Now the correlation appropriate for this purpose is point biserial correlation. Now you can see the table here. Subjects are 10, n equal to 10. So sex X are given, the male here, marks Y for here given, and then subject, then sex female, marks X, Y are given here. We calculate the mean here is 0.55, standard deviation 0.497. So mean also given here and the standard deviation. Now together mean mark 60.88, mean mark 68. Now a correlation has been calculated here and the answer is 0.38. So 1.7 covariance, that is the Pearson's correlation, point biserial correlation between sex and marks obtained is 0.386. The sign is The sign is arbitrary and need to be interpreted depending on the coding of the dichotomous group. The interpretation of the sign is the group that is coded as 1 has a higher mean than the group that is coded as 0. The strength of correlation coefficient is calculated in a similar way. The correlation is 0.386. So the percentage of variance shared by both the variables is R square for Pearson's correlation. Now same would hold true for point biserial correlation. The RPB square is 0.386 square equal to 0.149. So this means that 15% of information in marks is shared by 6. Now significance testing of RPB, let's see here. The null hypothesis and alternative hypothesis for this purpose are as follows. That is, H0 is denoted as null hypothesis, HA is alternative hypothesis. Since there is RPB is Pearson's correlation, the significance testing is also similar to it. The T distribution is used for this purpose with n-2 as degree of freedom. So T-test formula is given here. The T value for our data is 1.775. The degree of freedom is equal to n-2, that is number of participants or subjects, minus 2, that is 20, minus 2 equal to 18. Now the value is not significant at 0.05 level, hence we retain the null hypothesis. Now Phi-Coefficient, the second one, the Pearson's correlation between one dichotomous variable and another continuous variable is called as point biserial correlation, we understood. When both the variables are dichotomous, then the Pearson correlation calculated is called as Phi-Coefficient. For example, let us say that you have to compute correlation between gender and ownership of the property. The gender takes two levels, male and female. The ownership of property can be measured as either the person owns a property and the person do not own property. Again, dichotomous here. Now you have both the variables measured as dichotomous variables. Now if you compute the Pearson's correlation between these two variables is called as Phi-Coefficient. Both the variables take value of either of 0 or 1. Look at the data given in the table below here. You can see data and calculation for correlation between gender and ownership property is given. X as gender, Y as ownership of property, 0 for male, 1 for female, 0 for no ownership, 1 for ownership here, and then calculation is given down. The answer is minus 0.465. So the value of coefficient is found to be minus 0.465. The relationship is negative, is function of the way we have assigned the number 0 and 1 to each of the variable. If we assign 0 to females and 1 to males, then we will get the same value of correlation with positive sign. Nevertheless, this does not mean that sign of the relationship cannot be interpreted. Once these numbers have been assigned, then we can interpret the sign. Male is 0 and female is 1, whereas 0 is equal to no ownership and 1 is ownership. So the negative relation can be interpreted as follows. As we move from male to female, we move negatively from no ownership to ownership, meaning that male have more ownership than females. We can also calculate the proportion of variance shared by these two variables. This is R square equal to chi square equal to minus 0.465 square equal to 0.216%. So significance testing of pi, let's see here. The significance can be tested using the chi-square distribution. The chi-square can be converted into the divided by square by obtaining a product of n and chi-square. The chi-square of chi-square will have df equal to 1. The null and alternative hypotheses are as follows. You can see here the answer is 2.51. The value of the chi-square at 1 degree of freedom is 3.84. The obtained value is less than the tabled value. So we accept the null hypothesis, which states that the population correlation is 0. We should have the table to find out degree of freedom, and the table should be there where we can find out whether the answer is above or below the table value. If it is below the table value, we can accept the null hypothesis. It is above, then we have to reject it. One need to know that this is a primarily because of the small sample size. If we take a larger sample, then the values would be significant. Quickly note the relationship between this division square and chi-square. So one can compute the chi-square and then calculate the pi coefficient. Now the third one is biserial correlation. The biserial correlation coefficient is a measure of correlation. It is like the point biserial correlation, but point biserial correlation is computed while one of the variables is dichotomous and do not have any underlying continuity. If a variable has underlying continuity but measured dichotomously, then the biserial correlation can be calculated. Let's see, an example might be mood, that is happy or sad, and hope, which we have discussed in the first unit also. Suppose we measure hope with BHS and measure mood by classifying those who have clinically low versus normal mood. Actually, it is fair to assume that mood is a normally distributed value. But this variable is measured discretely and takes only two values, low mood, that is 0, and normal mood, that is 1. Let's call continuous variable as y and dichotomized variable as x. The values taken by x are 0 and 1. So biserial correlation is a correlation coefficient between two continuous variables, that is x and y, out of which one is measured dichotomously, x. The formula is very similar to the point biserial but yet different. You can see the formula below. You can pause the video and note down. So here the scores are given here respectively, and P0 and P1 are the proportion of the data pairs with X scores of 0 and 1 respectively. So we can calculate with the help of the formula and understand the distribution at the point which divides the proportions of P0 and P1. The relationship between the point biserial and the biserial correlation is as follows. So once you compute the RPB, it's easy to compute their RB. Point biserial and biserial we are doing. If you calculate point biserial first, then it will be easy to calculate the biserial one. Now tetrachoric correlation here. Tetrachoric correlation is a correlation between two dichotomous variables that have underlying continuous distribution. If the two variables are measured in a more redefined way, then the continuous distribution will result. For example, attitude to females and attitude towards liberalization are two variables to be correlated. Now we simply measure them as having positive or negative attitude. So we have 0, that is negative attitude, and 1, that is positive attitude, scores available on the variables. Then the correlation between these two variables can be computed using tetrachoric correlation. Now the correlation can be expressed as here, given here the table where E is the angle between the vector x and y. Using this logic, we can also calculate with the help of this formula. Now look at the following data summarized in the table here. That is the x variable attitude towards women. You can pause the video and please check it out how the negative attitude and positive attitude and the sum total is given here. The table values again calculated, and the answer is 0.722. So that tetrachoric correlation between attitude towards liberalization and attitude towards women is positive because it is below 1. Thanks for your attention and time. If you like the video, please do like, share, subscribe and comment below. Happy learning. I'll see you in the next video.